Lesson 3, Rational Exponents. At the end of this, you'll be able to write radical expressions as expressions containing rational exponents and vice versa, expressions containing rational exponents as radical expressions. Definition of b raised to the 1 over n. By the way, in case you can't tell, this is b to the 1nth. Okay? For any real number b and any integer n greater than 1, b to the 1nth is the nth root of b, except where b is less than 0 and n is even. We'll talk about that in a minute. Some examples. 36 to the 1/2. That's the square root of 36. Do we usually put a 2 here? No, we don't typically put a 2 there. Okay? But understand that it would be there, which in this just means that this is 6. This is 64 to the 1/3 is the same thing as the cube root of 64, which we know is 4. Now, an application. A gallon of milk costs, because I'm sure you all are saying, why would we ever use fractions and exponents? Well, here's one. A gallon of milk costs $2.69. How much will the cost of the gallon of milk increase by in 6 months, assuming a rate of inflation of 5.3%? Here's the formula that you'll use. Big C, well, that's your projected cost, future cost. Little c is your current cost. R is the rate of inflation as a decimal, and n is the number of years. Now, let's see here. A gallon of milk currently costs $2.69. That would be little c. How much will the cost increase in 6 months? 6 months is what part of a year? Oh, that's 6 out of 12, or 1/2 of a year. Assuming a rate of inflation of 5.3% as a decimal, remember that you have to move the decimal place 2 places. So this is 0.053, and that's our R. Okay, so what we're going to find, what we don't know, is the projected cost. Go ahead and answer this question. Pause the video, plug everything in, and answer the question. Okay, let's take a look. We've got the formula. We plug in all the numbers that we just described, and we find that C is $2.76. That's the projected cost. But that's not the answer to the question. The question said, how much would the price increase? So $2.76 minus the current $2.69, it would increase by 7 cents. Always make sure you're answering the question. Okay, definition of rational exponents. For any non-zero number b and any integers m and n with n greater than 1, we have b to the mnth is equal to the nth root of b to the m. And that m can be on the inside as a power or on the outside. Except when b is less than 0 and n is even. Why is that a problem? Well, remember that if I have the 4th root, if b is less than 0, then it's negative. There's no solution. If n is 2, then we can have imaginary roots. But everything else, it does not exist. Okay? There's no negative number that I can multiply times itself 4 times and get a negative answer. Now, there are 3 different ways to write a rational exponent. We can do 27 to the 4/3, the cubic root of 27 to the 4th, or the cubic root of 27 raised to the 4th power. It all evaluates to 3 to the 4th, okay, or 81. Now, your turn to rewrite. Think about what's easier, okay? I can do the square root of 36 and then cube it Or I could cube 36. I think it's easier to take the square root of 36. What is the square root of 36? Well, that is 6. So then I'm left with 6 cubed. And there's my answer. Okay, try 64 to the 2/3 and 81 to the 3/4. By the way, those periods there are not decimal points. It's just instead of a parenthesis or whatever. They're problem numbers. Okay, so try number 2 and number 3. Pause the video. Okay, were you successful? Notice here I took the cube root of 64 is 4, and then I squared it to get 16. Over here, I took the 4th root of 81. Okay. The 4th root of 81 is 3, and then I cubed it. It's a whole lot easier than cubing 81. Now, simplifying expressions. When you simplify an expression, there will be no negative exponents, no fractional exponents in the denominator, no complex fractions, fraction within a fraction. 2-year-olds should do this since it's all no, 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 no. The index of any remaining radical is the least possible number. Okay, least possible number. So there's several things you got to think about. Well, let's look. I have 4 to the 1/3 times a to the 1/2 times b to the 5/6. To simplify, I need a common denominator in all the exponents. So I've got 3, 2, and 6. What's common? 6 you say? Good. Now I've got 4 to the 2/6, a to the 3/6, b to the 5/6. 1/3 is the same thing as 2/6. 1/2 is the same thing as 3/6. Now I'm going to rewrite using radicals. Okay. Radicals, denominator is my index. So here, 6th root of 4 squared, 6th root of a cubed, 6th root of b to the 5th. They're all the same radical. I'm multiplying them so I can put them all together. I should also take care of 4 squared and just make that 16. If that were 4 to the 8th, leave it as 4 to the 8th. Well, actually, it wouldn't be 4 to the 8th, but 4 to the 5th. Okay? There it's all combined under one radical, and you can't get any smaller than the 6th root. Next up, we have x to the 1/2, x to the 3/4, x to the 1/5. 2, 4, 5. I need a common denominator. Oh, what will it be? 20, you say? Good. Okay. First, when you multiply like bases, you're going to add the exponents. So here I'm adding them, and to add them, I need like denominators. And so there's our 20 as the denominator. Now, I add all of those together. 10 plus 15 plus 4 all over 20 is 29 over 20. Ooh, that means I actually have x to the 20 over 20 times x to the 9 over 20. Why is this important? 20 over 20 is just 1, which means I have an x on the outside. And then this is the 20th root of x to the 9th. See? And in case you're not sure, this is like this. Okay? Now, when we come over here, puppy wants to play, we have w to the negative 4/5. Well, let's think about this. First, the negative tells me I want the reciprocal. Oops. I want the reciprocal. So now I've got 1 over w. Now, remember that both the numerator and the denominator go to the 4/5 power. So what do? I do 1 to the 4/5 over w to the 4/5. Well, 1 to anything is just 1. So I can simplify that. But the w to the 4/5, I want the denominator to have a whole or an integer. So remember that when I multiply like bases, I add exponents. So what do I have to add to 4/5 to get 1? Well, 1/5, which means I have to do w to the 1/5 up above too. So now I have w to the 1/5 over w to the 4/5 plus 1/5. Why did I do that? Because that will make sure I don't have a radical in the denominator by giving me w to the 1st power. Now in the numerator, I just changed the 1/5 to a 5th root of w. That's it. You got a couple of these to try. Now remember that this x to the negative 1/8, xy to the negative 1/8, this negative 1/8 applies only to the y. So that means I have x over y to the 1/8. Now, can I leave that in the denominator? No. So I need y to the 7/8 in the denominator, y to the 7/8 in the numerator. Now, x, 8th root of y to the 7th, all over y. 1/8 plus 7/8 is 8/8. Now, before you get too fancy here and you think you can do 32 divided by 4, you have a 10 and you have an 8. The indices are not the same. But 32 and 4 can be rewritten using the same base. I can rewrite this as 10 is the 10th root of 2 to the 5th. I can rewrite 4 as 2 squared. Now I have 2 to the 5/10 divided by 2 to the 2/8. Why would that be important? Simplify those fractions and you have 2 to the 1/2 over 2 to the 1/4. When you do that, recall that dividing like bases means you subtract your exponents. So 2 to the 1/2 minus 2, oops, not minus 2, but eraser. The 1/2 minus 1/4, 1/2 minus 1/4 is 1/4, and voila, 4th root of 2. You cannot do the division here. You can't combine the 32 and the 4, divide that, unless those indices are the same. Excellent. All right, try these two. Pause your video and try these two. Okay, so before you get too crazy about taking care of the square root of 5 in the denominator, let's look at this up here. This 5 raised to the negative 1/2 tells me that I need to make 1 over, this guy comes to the denominator, 5 to the 1/2. I still have 2 square root of 5. Well, 5 to the 1/2 is what? Oh, it is the square root of 5. So I have square root of 5 to square root of 5. But the square root of 5 times the square root of 5 is 5. So now I have 1 over 2 times 5, which is just, boom, 1 over 10. Nice, right? 1/10. Okay, this one gets a little crazy because notice it tells you got to multiply by the conjugate. I have to multiply it by m to the 1/2 plus 1, m to the 1/2 plus 1. You don't have to make the m minus. You just have to make this expression, instead of being a subtraction, make it into an addition. If this was addition, make it subtraction. Now, in the numerator, I have m to the 1/2 plus 1. 1 times anything is just itself. In the denominator, m to the 1/2 times m to the 1/2. Remember that when you multiply like bases, you add the exponents. So this becomes m to the 1/2 plus 1/2. M to the 1/2 times 1 plus m to the 1/2. Negative 1 times m to the 1/2 minus m to the 1/2. Negative 1 plus 1 minus 1. Now, plus and minus, notice right here you've got a zero pair. 1/2 plus 1/2 makes 1 whole. So I now have m to the 1/2 plus 1 over m minus 1. And changing m to the 1/2 into a radical, gives me the square root of m plus 1 over m minus 1. Easy peasy, right? Or is that really an old saying? Maybe I'm just old. Whatever. Okay, you get the idea. Let's keep going. All right, so here they have the same root. So I now have the 5th root of 6 squared y to the 8th. I have an odd index, so I don't have to worry about absolute values. Y to the 8th, I can get a y out. This is the 5th root of, I can't do anything here, so I'm just going to make this into 36. Y to the 5th, y cubed. Now I can take the y on the outside, and I have 36 y cubed underneath. Good deal? Nice. This one over here, I don't know, it was an example that was given in what is or was is your textbook. If you have a textbook, we don't necessarily distribute the textbooks, but this one, the c to the 1/2 has to come up. So you're going to have c to the 1/2 times c to the 2/3 minus c. When you multiply, when you distribute, okay, because this was in the denominator, the negative makes it come up, you get c to the 1/2 plus 2/3 minus c to the 1/2 c, and I'm just going to make this 2 over 2 because that's what 1 is. All right, from here, 1/2 is 3/6, 2/3 is 4/6, so I get c to the 7/6 minus c, excuse me, to the 3/2. Now, you can take a c out, okay? I can take a c out, and then I have the 6th root of c, the 6th root of c minus the square root of c. And you can't do anything else with it, okay? There's no other way because that's as simple as it goes. I'm not really a big fan of this problem because, while you can simplify it, it still looks kind of complicated. All right, for this guy, you can distribute that -2 first, or you can do it last. It's really up to you. I personally would distribute it so that I get 2 to the -2, x to the 4, okay, all over x cubed. Now I can see that I've got, this goes in the denominator, and x over x cubed leaves me with x up here, and this becomes 2 squared, which leaves me with x over 4. You could also drop the -2 down, bring this one up. You could take care of what's inside first, and then you'd flip everything around. A lot of different ways to approach it. All right, in summary, for any real number b and any integer n greater than 1, b to the 1 over n is equal to the nth root of b, except where b is less than 0 and n is even. And then additionally, if you have b to the m over n, that's the nth root of b raised to the m. Okay? That's it.